All right, hello everyone. I would like to introduce Kyle Fowler, Director of the Developer and Consumer Experience at Foursquare. If you're all ready, Kyle, take it away.
All right, great. Thank you, Annie. Uh, hey, everyone. There's a lot of content in this, so please just throw questions in the chat, like you're probably used to, and I will try and get to them if I can during the talk. Also, leave some time at the end for more in-depth answers if I can. So just jumping into it. Make sure. Uh, my name is Kyle. I'm our Director of Engineering for our developer and consumer business at Foursquare. For those of you who don't know Foursquare is, we're a location technology company focusing on how the real world and the digital world interact with location, and you have a bunch of products around there. And what we'll be talking mostly about today is our developer products, which we have two main ones: our Places API and Pilgrim SDK. A lot of people also know us from our consumer apps, Foursquare and Swarm. Um, so today, kind of want to talk a little bit about our journey to being a SaaS software company and uh, building out our Places API. So you know, Foursquare's original API launched in 2011. As the basis of our consumer apps, and at that point, we wanted everybody to have access to the same technology that we were using to build our apps, so that they could build similar experiences. So they were really developed together, um, and really developed to serve consumer application use cases. The primary user of the Foursquare API was Foursquare itself at the beginning, but as the company grew and use cases grew, we saw it getting a lot of traction with enterprise customers. So today, if you go and tag a tweet in Twitter, that's using the Foursquare API. Samsung, Uber, and other large companies started to use our API as a powerful source of truth for places in the real world, and a good API to build their features off of. Um, that was successful for us. It helped us grow to where we are today. But I think as the years have gone by, it really showed that in order to allow our API products to really flourish, they can't be attached to our consumer products. We need to decouple them and really dive deeply into what our API strategy is, and not hold it back by the features that our apps may need. And in particular, better supporting developers outside the US, what the dependencies are there, the challenges of deploying to different regions. Those grew exponentially and were decoupled from the needs of our consumer products. So building out a core global presence for this API and our platform was a main driver of our need here as we've grown the company. So using the Foursquare API as a foundation, we started to rebuild the Foursquare API, the Places API, with our goal of creating a refreshed developer experience and product to kind of take Foursquare to the next level as a software company. Um, so, uh, kind of briefly, kind of the ways we thought about building a new API and what it meant to us to have an enterprise level solution for companies both large and small to use. We focus mainly on improving SLAs, improving our developer experience, strengthening data quality, and a little bit hand in hand with SLAs, but performance overall as key drivers to what we thought would be successful in the market. So being able to offer 99.9% uptime, simplifying endpoints, better documentation, exploration tool, um, improve data quality, and reduce latency. And I'll get into each of these pieces as we move forward here. So getting into it, I think kind of taking a step back a little bit, what is a global API? What is enterprise? What is enterprise grade? I think it's kind of a broad term that we throw around. But to me, in Foursquare, what are the challenges that both you face when building an API, but that your customers want to solve? For us, usability is kind of the first thing. You want customers to enjoy using your API, for it to feel easy to integrate with and to understand. Reduces the or increases the ROI for someone coming to use your product, allows them to get value faster and feel a stronger connection with the product. Reliability and availability is one of the key tenets of an API that someone is willing to pay for. It needs to be always responsive, always returning successes, and allowing customers to get the value out of it that they want to see. And then, from an engineering side on, for Foursquare, how do we continue to make improvements? How do we not stick with the same product and allow us to mature the APIs without impacting existing paying customers, not adding continual breaking changes and work that we force on our customers in order for them to continue using our product. And then, consistency. If we have multiple API endpoints as a part of our API product, how do we make each experience internally consistent with each other? How do we make sure that, if someone's a Foursquare developer, they will understand how to use all of our products, all of our API products, and not have to change mindsets when looking at one API endpoint versus another? And then you kind of finally, how do we show people, your customers, how your API is performing and the value that they're getting out of it? And so, I think how our perspective on how we think we got it right, the key area here for me is really before you write any code, plan, just like you would any user interface product. I always think about an API as like a product with a UI component. It needs well structured design principles for path structure and authentication and error messages and style guides for responses and JSON or XML keys. You need to have the framework through which you design your API plan beforehand, so you can enforce that consistently while your teams are building the product, because the product is the response that you send back to the customer, and treating that like you would a UI with user testing and all of that is kind of critical. Also, the boundaries with which you'll build your endpoint. People will try and use your endpoints to solve a lot of problems, but have a perspective on which ones you're trying to solve. You want to leave yourself some room for not adding all features on day one. You want to make your design decisions that kind of focus on the use cases you plan for, and then leave some flexibility for continual improvement, like I mentioned. I think another important thing is what user experience do you want to enable with your APIs? Is it someone consuming the endpoint through scripts in their deploy process, or is it someone using your API to power a feature in their consumer application? Those answers will change how you should think about the design decisions that you make in your API. For us, it's very consumer focused. The end users of our API customers are often mobile or web users, and so that kind of impacted a lot of our design decisions. And so, I think little image of our developer console. I think focusing on developer ergonomics really early, because once you launch it, you can't really change it. Uh, you need your data schemas and rules for how you render parameters and response fields, your response structure for error messages, authentication, whether it's in a header or in a API parameter, and then how you version, how you make changes, semantic versioning in the path. Um, those are all the base level kind of important things, because those need to not change as frequently as possible. You don't want to cause churn for your customers. Uh, you know, Sorry. And the biggest thing that I think we focused on at the beginning, right now the GraphQL and REST debate is growing, and we kind of made the decision early on to stick with REST, but we also knew we wanted to enable customer use cases where they could select the fields that they want from the response, because that impacts how they're billed for our products. We have some data that's premium, that you can pay more to access in the same API responses. So that kind of lends itself more towards GraphQL. But as we step back and kind of looked at the overall adoption, and the tooling supporting GraphQL, we felt it wasn't quite something that we would make the primary usage of our products. So inevitably, that means we had to implement a little bit of our own field selection, which some frameworks have. We are a Scala shop, and there's um, things like Sangria in Scala that supports GraphQL, but we ended up building our own field selection to offer similar ergonomics to GraphQL, but in a way that we felt was more globally adopting than jumping into GraphQL. But obviously, we withhold that option for later. Um, so, and I can go into more depth on any of these things at the end if we want. I think also, obviously, a large part is documentation. Um, you need a plan for how you want to document your endpoints. How do you keep them up to date? That's usually the biggest issue with documentation, is that someone changes the code and then it starts to drift from documentation. How do you plan before you even launch the product, how you're going to document your code? And working with our technical writers, getting them in early in the process, they can call out internal inconsistencies. They can make sure that structurally everything makes sense before it even sees customers' hands. At Foursquare, we document our code through annotations, and generate Swagger docs through our web framework, and then those get published on every deploy, so that the live API documentation is always in sync with what customers will see. So we had to make that decision beforehand because it changed a lot of things about how we wrote our code. So, and then the other part, there's documentation, then there's onboarding to your product. Your API is the interface that you offer through curl or whatever, however people are accessing it, but it's also the console environment with which you allow people in to configure your tools, to set up their API keys, to view their usage. Walking them through those steps would really increase success in that funnel, from people looking at your documentation to actually ending up using your product. And then moving a little bit to the SLAs. For us, enterprise means we have global customers who are hitting our endpoints at all times of the day, and our engineering offices are in the US, so we need to have around the clock support. For a lot of engineering teams, that can be problematic. Adding pagers to an on-call rotation, making sure that you have coverage to match your customer expectations. Or are you building a 9 to 5 app that can deal with 30 minutes of interruptions at 2 a.m. Based on your customer needs and your expectations, you have to change kind of how you structure your engineering team to be able to respond to support your SLAs. So yeah, SREs, on call, all dependent on kind of what your needs are as a company. For us, I think building consumer applications, end users always expect 0 errors, and given that we have our global customers, we have our on-call teams to support our live APIs, and my engineering teams collaborate with our infrastructure team, build out a new platform on Amazon EKS for our global deployment. Work with them to provision, configure, and network all our clusters around the globe together, and failovers and all of the things to make sure that the system will do as much as possible and humans don't have to be woken up at 2 a.m. But also, going. I'll get to that in a second. So the next, I think you can jump to writing code, but also, what are the metrics that you care about when writing an API? Usually the two, well, I mean, maybe these are obvious, but latency and availability. How do you measure those things? How do you be transparent with your customers about the metrics that you're monitoring and your adherence? Metrics, you can make numbers say anything you want. So metrics are always relative to the lens at which you're looking at them. Be clear in your definitions. There's internal server latency, there's external latency from a customer in Asia and hitting a data center in the US. What are all of the ways that your customers could interpret the metrics that you share with them? So, for example, when we were launching our new API product, we took it global for the first time. We know customers had put up with latency of data crossing the ocean to our AWS region in the US. They were fine with it, but we knew that we wanted to offer better availability and latency. So, this is kind of it's a small graph of when we finally turned on our API region in Singapore, just the impact that it had on customers. And while they're still getting the same product, this is a better experience for them. Going from 1 second external latency to 100 milliseconds. Still the same product, but a lot more usable in real-time scenarios for our customers, and in the end, their customers as well. I think one thing also to note on latency is load testing. We have an internal framework called our Dark Tester, where we replicate traffic from one API endpoint to another, have multipliers, stress the system to its limits before it starts taking live production traffic, make sure that we have all of our tuning set on the auto scaling parameters, and all of our alerting works. Make sure to really test it till failure, know how many QPS you want to support, test it beyond that, and make sure that you can recover in different scenarios. So we did probably 2 months worth of dark testing against already live API endpoints to make sure that when we launch, we would be able to hit those numbers for our customers. So I think there is an US East 1 AWS outage going on as we speak that is causing some problems. Sometimes you can't control everything. And then finally, just a few things to keep in mind, some important. Track your costs. As you go global, The replication of data and services will also double your costs in a lot of cases. Sometimes you can scale by adding replicas to your databases that are only incremental costs, but going global from a data center perspective is it can be very expensive. Plan for your customers to audit the performance and use your product in ways that you never expected them to use it. They will do things like hit your API 5 million times between the hours of midnight and 1 a.m. because they have a daily cron job and then never hit it the rest of the day. How do you handle those? Either through rate limiting or scaling quickly to handle those requests. They'll do weird things and you'll have to be able to handle that. Security, obviously very important, especially if you're dealing with customer data or PII. Making security a part of the process while you are building the code instead of after the fact is an important step to the development process, which I forgot to mention earlier on. And I think especially in the enterprise realm, legal is an important component to launching these products and maintaining these. If you're going to offer contractual SLAs, what are the customer's remediations for when you don't hit it? How do you track those numbers? How does legal interpret those in your contracts and allow you to move forward as a business? And then things like terms of service and all data agreements that are usually required when you sign up for an API. And that is it. I always want to leave legal for last because they are important and they often get forgotten until they come barking down your door. That is all I have. And I think we have about 3 minutes for questions. Happy to go in depth on any of the technical pieces. But yeah, anybody has any questions at all, happy to answer. I guess this would be my plug to go to developer.foursquare.com, sign up, and you can send me some feedback. If I had to do it over again, is there anything done differently from the start? I think we spent a lot of time internally focusing on framework that we were going to use to write our code. I think ended up delaying us a little bit. I guess this is more internal than external, but we knew we didn't want to write our own web framework. But the selection process, both I mentioned were Scala, but that left us open to like all JVM-based web frameworks, and even like the idea of do we switch to Python? Like I think we probably spent too much time focusing on that at the beginning. We ended up using Finatra, which is a open source Scala web framework. So that's on the internal side. On the external side, I think as we were migrating from an existing API to a new API, I think being very clear, if this applies to you, being very clear about how one moves from one to the other, what's the difference, what are the benefits, why someone would migrate. I think that's something we could always improve on at that customer communication. And then, for example, one thing that we should have done better is also we missed testing in one use case environment that like the first day we launched it, someone said, hey, this doesn't work because you're missing a header a cross origin security header. I was like, oh, well, we missed that test. So there's always things that can improve. Yep. Looks like we're at time. Thank you for your questions and attending. I appreciate it. If you have any questions, you can find me on LinkedIn. Happy to answer, or Twitter or anything like that. Appreciate you all. Thank you.